Okay, so question 3, right? They basically want us to find the graph of a position of an object with respect to time. So they want us to find the position time graph. And what's the scenario that they describe? The scenario that they describe is that it started out from rest, right, and underwent positive acceleration for some time, followed by constant velocity. So the position time graph, right? So positive acceleration, this will look quadratic. So for the position time graph, right, positive acceleration would imply that it looks quadratic over time, and constant velocity will look like it's linear over some time. So you can see that this is quadratic and then it's constant, right? So constant is kind of linear, but it implies that the velocity is 0, right? This is linear and this is constant, so this is definitely wrong because it shouldn't be linear in the first region. This is quadratic and then it's linear, but the issue with this is that we know that the object started from rest, so the initial velocity is equal to 0. So the gradient at t equals to 0 should be 0. But in this case, we see the gradient at t equals to 0 is non-zero, so this is wrong also. This one is non-zero gradient at the start also, so it's wrong. This one is initially quadratic, after that it's constant. After that it's linear. So this matches our description. So the reason why this doesn't match our description is because over here, after going acceleration, right, it will have some constant velocity from the acceleration unless suddenly it decelerated. And this sudden jump would imply that there was some amount of this sudden jump would imply that there's some sort of infinite acceleration the moment it finished accelerating. So that's why E is the correct answer.